How does a closed system behave in thermodynamics? Imagine a sealed container where nothing can get in or out, but heat and energy still flow across its boundaries. That's what a closed system is in thermodynamics. It's like a jar with a lid that keeps the contents inside but allows heat to pass through the lid. This setup helps us understand how energy moves without the complication of matter entering or leaving. In thermodynamics, the main idea is that energy can change forms but is never lost. When we look at a closed system, the amount of matter inside stays the same. No new molecules come in and none escape. But energy can still be exchanged with the surroundings in two main ways: heat and work. Heat is energy transferred because of temperature differences. Work is energy transferred when a force causes movement, like pushing a piston or expanding a gas. The first law of thermodynamics, which is about energy conservation, applies directly here. It tells us that the change in the system's total energy equals the heat added minus the work done by the system. If the system absorbs heat, its internal energy increases. If it does work on the surroundings, its internal energy decreases. The key point is that energy is always conserved, just changing form or location. Inside the closed system, energy is stored as internal energy. This internal energy depends on how molecules move and how they are arranged. When heat flows into the system, it increases the internal energy. When heat leaves, the internal energy drops. Work done on the system, like compressing a gas, also increases internal energy. Conversely, if the system expands and does work, its internal energy decreases. Since no matter crosses the boundary, the system's mass remains constant. This makes analyzing closed systems easier compared to open systems, where both mass and energy can flow. For example, think of a sealed, insulated bottle of water. If you heat it, the water's temperature rises and the internal energy increases. If you then let the water expand by heating, it does work on the container, changing the internal energy accordingly. Practical examples include a pressure cooker with a sealed lid, where heat is added and pressure increases without losing water. Another example is a piston cylinder device in engines, where the piston moves up and down, doing work but keeping the amount of gas inside the cylinder constant. Although perfectly closed systems are rare, the concept helps us understand many real-world processes. To sum up, a closed system keeps its matter inside but allows energy to flow in and out as heat or work. Its internal energy changes based on these energy exchanges, following the law of conservation of energy. Heat transfer depends on temperature differences, and work involves mechanical actions like compression or expansion. Knowing how closed systems behave helps us understand energy transformations and design better engines, refrigerators, and many other devices.